Now we'll look at the first of two function transformations that are applied to the variable inside the function, not outside of the function. Our base function was x squared, but now we definitely do not have x squared, and we're not saying find x squared and then add 1. We're making a change to the variable itself. Let's look at what would be our ordered pair solutions. If we put in -2, we've got to add 1 first, so now we're saying do -1 squared, and we get +1. If x is -1, first we have to add 1 to it to get 0, and then 0 squared equals 0. When x is 0, 0 plus 1, and then 1 squared equals 1, and so on through the table. Now we do see some familiar results. This pattern 1, 0, 1, 4, we see it again in this table of ordered pair solutions. And it even looks like these values have been shifted left, shifted to the more negative side by 1, even though we said we're doing x plus 1. Now, if you're thinking about the vertical transformations, things that we were doing to the function, we were altering its result after we found the function value. Adding 1 definitely would shift everything up 1. But when we add 1 to the variable before we actually evaluate the squared part of this function, we're actually making a change of the original point. We're saying x plus 1. You could actually think of it like we are shifting the entire coordinate plane. We're shifting the x-axis 1 unit to the right. This x plus 1 is shifting the coordinates to the right, and if we shift the coordinates to the right, the result is like the graph is being shifted to the left. Let's actually look at this graph as I try to describe this again. But again, for now, let's notice that we see some same results, and you could see why. Like when we took -2, once we added 1, we were basically doing what we did over here when we plugged in just the -1. So definitely we're seeing results that are just 1 away. And let's look at the graph now. So the base function f of x equals x squared. And here is the graph of those ordered pairs. -2 gave us 1. -1 was 0. 0 was now 1. 1, 4, and so on. 2 is off the page up here. But what appears is a shift to the left. The graph has been entirely moved 1 unit to the left. So work with me for a second, and I want you to focus on the graph in blue. And what would happen if I made this graph stay exactly where it is, but I grabbed this x-axis and I pulled it 1 unit to the right? It would mean this vertex of the parabola wouldn't be at the origin anymore. If I pull all these numbers in the number line to the right, the vertex is now at -1. So that's the graph that we see here. The same parabola, exact same series of points, but now the vertex is here at -1. It's been shifted left. Every single point has been shifted left 1 unit. So we can still think of numbers being added or subtracted as shifting the graph, but we have to understand that this sort of a move to the variable, not to the result of the function, but actually in that function right on the variable, it's working the opposite of what we see. When we see a +1, it's shifting left 1. Let's keep working with this example. Let's go to the reciprocal function, and now if I want to add 1 right to the variable, I have to go right here into the denominator and do +1 here in the denominator. If I was a +1 behind, that's our D transformation. That's taking the function, keeping it as is, and adding something to the end of it. But what we're looking at this time is adding a number right to that variable inside the function. That's giving us this 1 over x plus 1. Now if we complete our ordered pair solutions, -2 in place of x, once we add 1, it's now a 1 over -1 equals 1. And we're seeing the same pattern that we saw over here where our function values have kind of been shifted 1 unit over. We used to see undefined when x equals 0, but now we see undefined when x equals -1. And the value of x equals 0 is what we used to see when x equals 1. So there's some very similar things going on here. And what would be our next point here if x equals 3? Reciprocal is 1/3, and now we see it within this range of -2 to 2. Let's take a look at the graph, the original base function, and now the graph of 1 over x plus 1. We added 1 to the variable. The result is that the graph shifted left 1 unit. Every point moved left 1 unit. This point here, left 1 unit. So this change of adding or subtracting a constant, now so far we've just looked at adding, we've seen that adding a constant shifted the graph to the left. Again, just to kind of show it to you again, there's the base function, shifting it left 1 unit and comparing it back to the original. So let's sum it up. We're talking about a transformation of adding a number right into that variable inside the function. So x plus c is how we're representing it, not like plus d, which was back here after the function. Adding a constant to the variable, if we're dealing with a positive number, we're shifting left. So opposite of what you might guess. When it's a horizontal change, we tend to see things working opposite of what we think. A number added in is really a shift to the left. Now what if we use some negative numbers, of course? X minus 2 squared. So our function values come out this way. If we're putting a negative 2 in place of x, the takeaway 2 has now made it a negative 4 squared is positive 16. If x is 0, 0 minus 2, negative 2, and that squared becomes positive 4. But again, we do see some of these values of the function repeated. They've been shifted a couple of units over, a result of the x minus 2. Let's go over to our other function and work this table. 1 over x minus 2 will give us these function values. If we put in a negative 2, now we're looking at 1 over negative 4, and so on. It's when x equals 2 that we see an undefined value, because denominator would be 2 minus 2 equals 0. So let's look at the graphs. Our base function x squared, and here is x minus 2 squared. Every point shifted to the right 2 units. Here's the base reciprocal function, and 1 over x minus 2, every point has been shifted to the right 2 units. We can sum this up by saying that we're shifting to the right when c is less than 0. When we see x minus a number, we're shifting our graph to the right.